Hello, welcome to this session. In the last session, we have discussed about the grouping of batteries, means how we connect the batteries in series and in parallel connection. If in a circuit network, if we have a series connection of battery and parallel connections of battery, first we simplify the battery networks. First of all, we simplify the battery network. After simplifying the battery network, we connect those battery to the external world. External world for this case is this one. So here in this problem, we have two batteries with some internal resistance. Internal resistance of the first battery, E1, is 0.5 ohm, and E2 battery has internal resistance 1.0. And we already knew from the last lecture that if we have internal resistance like R1 and R2, and if these batteries are there in series, we simply add the internal resistance to create the equivalent one. So here we have internal resistance R1 and R2. So add this up, you will get total 1.5 internal resistance. Okay, so total 1.5 as internal resistance. Let me write somewhere. Okay, internal resistance, you have R0 is equal to 1.5. Okay, 1.5 ohm. So you have the circuit like this now. Some internal resistance, and that is connected to outer world. Your outer world is something like, let's see, 4.5, 3 ohm and 6 ohm. Okay, 4.5, 3 ohm and 6 ohm. Here you have 4.5, and then you have two resistance in series, 3 ohm and 6 ohm. This is 6 ohm. Moment you got the simplified network with R0 and E, your problem has become as usual problem, means regular problem. No any complexity now. Right. Now E R0 and E, what is E? E is total EMF, E1 plus E2. Our E1 is equal to 4 volt and 8 volt. E1 4, E2 8. E1 plus E2 will be equal to 4 plus 8, means you have 12 volt. R0 is 1.5. Now what you will do, simply you add this up, because these things are there in parallel, add in parallel, then add this one in series with R0, get the total current. This total current will get divided over here, right? This total current will get divided over here. By intuition, we can simply take, like, here you will get 2i, here you will get I. So yeah, because it's a less resistance, right? So first I will find out the total current. Total current will be equal to E by total R, right? And E by total, this is total current. E by total R, E is equal to 12, and total R, this 4.5 and 1.5 is in series. 4.5, 1.5 means total how much? 5, 6, total 6. And here these two resistance in parallel means 6 3 ja this 3 parallel to 6 will be equal to 18, 6 3 ja 18 by 9 means 2, which will be equal to 2. So here you add this up to, you will get 12 by 8. 12 by 8 means 3 by 4. 3 by 2, I guess. That is total current. Okay. Now we need to find out the voltage potential difference between the 6 ohm. Here you need to find out the potential difference, or we need to find out the current passing through 6 ohm resistance. Let's have a look. Calculate the current passing through 6 ohm resistance. Okay. The one thing is very intuitive and very clear, like current passing through this will be double than the current passing through this, like simply because it has less resistance. Current is inversely proportional to the resistance, right? So this is intuitive one. Another one you can find out exactly by using Kirchhoff's law and all, but I will go with the intuitive law, right? The first means here I will say this is current I1 and this one current, here current I2. Simply I1 by I2, I1 by I2 will be equal to 2. Okay, and total I1 plus I2 is 3 by 2. I1 plus I2 will be equal to 3 by 2. Okay, now let's take this. I means I1 is equal to 2I2, means 3I2 will be equal to 3 by 2. It means your I2 will be 0.5. Simply I1 will be 1, because total I1 plus I2 is 1.5. So 1 ampere current, and here 0.5 ampere current. So in I2 means here in this 6 ohm resistance, I2 is 0.5 ampere current passing through 6 ohm resistance. That is the way to calculate the current. If you have a batteries mesh or batteries network with internal resistance, right? If battery's polarity is same, then you add up. If it's different, then you add with the correct polarity. All right. Okay, see you in next lecture.